Welcome to another session with my little Tangerine Tiger. Today I think we're going to have a little bit of a tidy up day. Hopefully by the end of this session we'll actually be able to fire up the actual laser tube itself. I just need to make sure everything's tidy before I do the final bits, because I don't want to be tempted into using the machine and having it half finished. That's why I've been a little bit meticulous about tidying things up as I go. So one of the first things we're going to have to do is go in and modify the vendor settings, because if you remember the last time when we swapped the belt over to the flexible rack and pinion system, then everything was reversed in the X direction. A similar situation will occur whenever you get a failure of one of these micro switches. When you turn the machine on, it'll go bonkers and do silly things. So one of the first things I'm going to do is to put the head to the middle of the machine, or even to the front of the machine in the case of the Y-axis more or less, because it's going to move slowly in these directions. This one's going to go in the wrong direction and away from that, but this one's going to be correct and move towards that. If it's out of control, the simple solution is, once it starts to move, just press the escape button and it will stop. Finger on the escape button and there we go. So the machine is now stopped safely. It says all sorts of strange numbers on the keyboard, but that's not important. We've still got power to the machine and it's under my control. So we're already hooked into RD-Works, and we'll go to vendor settings, RD8888. So the first thing we do is press read, and that will also test that we're connecting up to the machine properly. And there we go, we are. It tells me we've got 500 in X and Y 300, which is correct. Okay, so the X-axis at the moment, direction polarity is negative. So we need to make that positive, and that will change its direction. We've got to change this keying, because our direction keying is the wrong way round. So invert direction. We'll remove that tick and we'll write the information back to the machine. Now I'll press the reset button and see what happens. So Y is honed, X is honed. We're back in control. Just check the keys. Left, wrong way round, right. So we need to go back into the vendor settings and just put that tick back. Okay, so we've reverted the keying, and let's just check. And now everything's going the right way. Left, right, backwards, forwards. Well, we could just see where our limits are now. So if I press the down arrow key, we'll find out how close Y is to the front of the machine. And look, we can have at least another 10 millimeters here, and we're clear of everything. Let's go over to the extremity over here and see what happens. And on this side, look, I can get my fingers in there, so I'm not going to hit anything there. So I could add another 10 millimeters to the width and another 10 millimeters, so I can make this table now 310 by 510. So back into the vendor settings, and X, we can make the breadth across here 510, 510, and then we can make Y 310 and write that back to the machine. So we should be able to drive this another 10 millimeters in this direction now. And there we go, we've still got 5 millimeters clear there, we're not hitting anything. And then we should be able to go that way another 10 millimeters as well. And sure enough, we're completely clear here as well. As you can see, I've managed to find some 5-volt LEDs, self-adhesive. It's amazing what you can find when you dig around in cupboards. And there just happens to be enough to run backwards and forwards, so I can have 2 strips underneath there. So we can now see how beneficial this side entry is. So yeah, I've had to make a small modification here. As you can see, I've had to put a cutout in this motor plate to allow the cables to track down underneath into the cable tray. Otherwise they would have stood out the side here and they kept on getting caught on various things. So yeah, everything's worked out quite neatly in the end. What I'm going to do here is I'm not going to rely on the thread in this plastic here to lock this nut in. What I'm going to do is I'm going to use some M5 half nuts. Now these are very thin nuts. So we've put our lock nuts on there, and then this 5mm thick material, I've counterbored it about 3/4 of the way through so that it fits over the nuts. And then we've got some wing nuts on here so that it's easy to take them off. Now I noticed as I was pulling under there that the solenoid valve for the air assist was warm. And of course then I checked here and found that it was manual on. So I've turned it back to auto, and that means now the solenoid is off, which it will be most of the time. It'll only be overridden when you need it. I also remembered we've got a little bit of tidying up to do in here. Look, we've got this big gap in here where I tried to fit this back plate and I didn't need it, so we're going to have to cover it over because we need something to do this y-axis switch properly. It wasn't done properly before. As soon as you undid the connection, this fell out into the back. Well, it won't any longer because I've made a proper connection here. And I remember to put the nut and the washer on the back here. Nothing's going to hit or clash. No, there's nothing wrong with the camera. Look, you can see the control panel over here on the right. But I just want to show you this. You can see the table without getting blinded. Okay, apart from playing with the lights, what else have I been doing? You don't need to see me doing this. I've just made a lovely nameplate to go on the side here. I've repacked and tidied up all the cables in there. Okay, well, we've wired the tube up now, would you believe? And everything is tidy and ready to go. But before we do that, we've got to set the vendor settings. Now we've got to go into laser. And the first thing we're going to select is one tube. Oops, the first thing we're going to do is select is read. Forgot about that. Glass tube. No, it's going to be an RF laser with pre-ignition. So the pre-ignition voltage is set within the laser system itself. It's one tube. And the attenuation is going to be 0. So we've got minimum power set at 1%, which is fine. Maximum power 99. The laser frequency, now that's the actual base frequency of the pulse width modulation. That's exactly the same as was set for the glass tube, where the only thing that was changing was the duty cycle. It was a constant 5 volt DC that was then switching on and off proportionately with the PWM signal to give us an output voltage of anything from 0 to 5 volts. If you don't know quite what the duty cycle means, then go and take a look at duty cycle on Wikipedia. Pre-ignition frequency, preset to 5000, and I think that's the value that I was recommended to use. And the pre-ignition pulse, 0.5%. I think again that was what was set. Water protect, we don't need water protect because we haven't got any water protect. So we should be able to write that back. We should be ready to give this thing a little pulse. So I think we'll start off by setting the pulse max power to 10%. Enter. And then we'll just go and check somewhere else, which is the laser set, and we'll see how that is configured. At the moment it's set to continuous, which means as long as I put my finger on the button it will pulse. I'm happy with that because it then means it's under my control. Before we do that, let's put a target on the mirror, should we, and see how well we've got the tube set up in relation to mirror center. Now this is supposed to be a very small 2mm diameter beam, And if that is the case, then we have, on a 25mm mirror, we've got a lot of scope for being off centre, and it really won't matter. Well, here we are. We've reached that big moment. There's a certain amount of anticipation on my part, because I've got no idea what to expect. I don't know whether these fans are going to suck or blow. I'm expecting to see a couple of lights here, but let's turn it on and see what happens. Lace on. Green light. So they're sucking. Well, that's good news, because it means all we need is ventilation holes in here to allow the air to come out. And we'll have a quick press of the pulse button. 10%. Maybe I'm missing by a mile. Let's see where we are, shall we? Well, that's a long way off centre. Why am I so far out, I wonder? Well, the good news is we know it all works. The bad news is I'm not the perfect engineering expert you think I am. The good news is that we've only got 2 fixing screws on here to clamp it in place. And I should be able to just swing this out like this, because there's a screw at the other end there which is holding this in. And now I can get access to this mirror. The good news is I can run it like this, because all I'm trying to do is to align mirror 1 to the laser tube. And I should be able to find almost the perfect centre position now, because the mirror is just standing there doing nothing. Well, that's not bad. Now that's perfect central alignment. So what we need to do is nothing more than put something like a 5mm hole in there, I suspect, and that will allow me to lock that mirror in that one position, which is all I need. But hey, I'm a long way out, so I've got to move the centre of that pattern across there 12mm to line up with the settings that I've got. I've designed this piece of channel here to suit a glass tube, and this lines up with the centre of that channel. Okay, so here's the channel. And I've made the centre of my fixings here, the slot, so that I can adjust it backwards and forwards on the centre of the tube centre line. What I've done, I've very conveniently mounted the 4 fixing pillars for this laser machine symmetrically on that same centre line. But the laser beam is not on that centre line. The laser beam is on a different centre relative to the mounting points. In trying to be a bit of a cheapskate and use this piece of equipment for 2 purposes, I've created a bit of a problem for myself. So yeah, it's easily overcome with just 1 fixing hole. Just in case you're worried, I've covered over the output window for the laser. When I did that blowing, I just removed the tape again. It's a lot easier to rotate the part than it is to rotate the screw. You might as well have a front row seat, mightn't you? It's a very small beam, so it's not going to worry us if we're very slightly off centre. Now comes the second problem, because now what we've got to do is to move this whole thing backwards and forwards. Here's my mirror. The corner of that mirror is a certain distance away from the wall of the machine. Now, my number 2 mirror is exactly the same style mirror as that, and it's sitting at 45 degrees out here. But I'm pretty sure that that corner and that corner will finish up at virtually the same dimension. So I've got to go round to the front of the machine now and measure how far the number 2 mirror is away from the wall of the machine and set this one to that same dimension. You don't need that noise on for the moment. In practice it's easier to measure that corner, 91.4. So it's got to come this way quite a long way. It's about 91. So that's not far off. Now the reason why I need to know that is because I've got to punch a hole through here fairly accurately. And to do that, what I'm going to do is to stick that on there. I'm going to check the gap on my mirror to make sure they're all approximately the same. Here, here and here. My mirror almost in a vertical plane at 45 degrees and cause the reflection to bounce onto here in pretty close to the correct position for me to drill a hole through, because I want the smallest hole possible through there to point to mirror number 2. Once I've got this thing set, I don't need a big hole for adjustment. So I'll let the laser do the work for us. And there it is. Yep, that's pretty good. So now we go and check how that beam is hitting mirror number 2. Now I'm going to loosen the slide at the back here. And I'm going to drag the laser back by 1/4 inch. Turn the laser on. We'll see what effect we've had. We've gone too much now. Minor adjustment and a little bit more. We don't have to be perfect, but we can be, because I've got all the adjustment in the world that I want, and that should be just about spot on centre. And now that I've tightened the laser up and clamped it down, spot on centre. Basically made sure that the beam is in approximately the right place at this end. Let's put a target on there and start alignment with the x-axis for real. So there's our target burn. Pretty central. And here comes our alignment burn now. We're not on the mirror. That's not too far off. It's probably right on the right hand edge of the target. It's right over here now. We're pretty close. Now you can never set this in one, because it is an iteration process. Well, I've just shut down the machine for a few moments because I feel I need to explain what I've just said. Iteration process. Many people set their machines up and they follow this routine of target set, but they don't actually realise what they're doing. Let me try and take a few moments to just explain the technique that you're actually using. Here's the bearing rail, And what we're trying to do is set the beam, at the moment it's a red beam because it's reflected off this mirror here at a funny angle. We're trying to set that red beam to this position here, which is the dotted mauve line, which is actually completely parallel in both the vertical and the horizontal direction with the bearing rail. So that's our target that we're eventually trying to achieve. The first time we put mirror 2 close to mirror 1, we don't know how this beam is reflecting off of mirror 1. And the first time we do this, we're going to produce a green target burn on mirror 2. So we move mirror 2 a long way away, and hey, here's our green target, and our beam is nowhere near the green target, so our burn is out here. So we adjust mirror 1 to bring this beam onto target. So now what we've got a blue beam. And you could easily be forgiven for thinking that you've now set your machine correctly, because you've actually set the beam onto the target and it perfectly matches. It's not quite as simple as that, because now when we move this mirror back to position 1, we shall find that the blue beam, when we fire it again for the second target, is actually making a target burn here. The first target burn was here, but the second target burn is here. So now we move this mirror away, and here's our target that we're aiming for. And of course, look, the beam is pointing here at the previous target. So now we have to adjust the beam yet again at mirror 1 so that it points to the blue target, which is our second target. And as you can see, now that we've gone and set the orange beam to target number 2, we've got a lot closer to perfection. We're not perfect yet, and if we go through one more iteration, i.e. one more set of corrections, we shall be pretty close to perfection. So you're not a failure if you didn't do it in 1. You're pretty lucky if you manage to get it in 2. The chances are you're going to have 3 attempts, or maybe even 4 attempts, to get your distant burn the same as your target burn. This is what I describe as an iteration process, a process of gradually creeping towards perfection. Pulse. And we're going to have to make probably one more adjustment. Now, as we're not interested in absolute position for centre, we can turn the target over, do the same thing again, okay, that's pretty good. Because we'd like to be a little bit more perfect than that, we can now move the beam back slightly across that way without affecting the adjustment that we've just made to the y-axis. We've just set the y-axis up, but what we haven't done is set the beam so that it's on the centre of that mirror. So we'd like to move the beam across about 3 millimetres, more or less on centre. We're high, remember, but don't get upset, because we've got to clamp the beam back down again. And we should be back on centre in more or less both planes. And there we go. The one thing I will say to you is that once you have been playing with this beam, you'll notice that there's some condensate formed on the mirror there. The fumes come through the paper. It will eventually disappear. But I've got some toilet tissue here, or some lens tissue, whichever you fancy. The proper stuff is lens tissue. And we can just clean that mirror. There's nothing more than just a hazy residue on the mirror. At the moment, you'll note I haven't even got a mirror in number 3. It doesn't matter. I can still set up X without that mirror in place. Now, the gantry lights in this instance are annoying. When I switch the gantry lights off, all of a sudden you could see this target. They were causing the aperture to close down. There's a good logical reason for me, at least, to have my lights switchable. Pulse. It's way low. When I look at these, I can see that I'm right at the top of the adjustment. It's not important at the moment, but we will just drop that down to roughly the halfway point in the adjustment, which is about there. Right, let's not worry about where it is in relation to centre at the moment. What we're more interested in is where it is when we get over to the other side there. I suspect we're quite low, so let's just test it. Ooh. We're over here somewhere. Not only are we low, we're way off target there. Look, we're up here. So we've lost quite a lot of power as well, and the beam has grown. We need to raise the beam up. We need to send it across. We now need to lift it up a little bit. Okay, now we'll compare it to our target. To get that hole there roughly on the same centre line as the target, because that is approximately the centre that we're aiming for. So it's quite a nice sharp beam there, and yet when we come across to this end, well, we're well lined up, but the beam itself is pretty poor. I'll show you what I mean. It's no longer a crisp black beam. Look, it's taken a long time to burn. Mirror 2 is causing some sort of problem. I'll just go and get some proper lens tissue. Depending on the sort you get, they all feel slightly different. This particular stuff feels similar to toilet tissue, which is why in an emergency I will use soft toilet tissue. Never use kitchen roll, because kitchen roll has got kaolin in it, and kaolin is an abrasive and it will scratch the surface of your mirror. Without fixing the mirror on, let's just see if we've improved the pulse. At least it's the same size now. It's not quite as dark, and I noticed I had to press more on the pulse button to get to that texture. So I know from a feel point of view that it's lost power by the time it gets to this position here. I might change that later, but for the moment we're not going to get too concerned. We'll just go back, we'll put the screws in, and we'll just check that we haven't messed the alignment of X. Just fitted up the mirror holder onto this head, and to put the mirror in is normally pretty easy, because look, you undo these two screws that are diagonally opposite and you should be able to just drop the mirror in. You might need to undo the screws just a shade more. But the mirror should go in without the screws coming out. We set these grub screws here so that we've got an even gap along the top and the bottom, around about 1.5 mm. That will be determined by this screw here. So you've got a pivot screw in the corner here which doesn't do anything, but you need to make sure that you start off with it in about equal. Now just remember the nuts on the top here are loose, so put your finger behind here when you tighten these up. Right, so what we're more interested in at the moment now is firing this beam across here and going down onto the table, anywhere onto the table. Just put our piece of card down, shall we? We'll have a go at burning. Well, first of all, we're going to bring the table up as high as we can. Pathetically slow, isn't it? Now, bringing the table up high is revealed that I've got a potential clash here. I've still got an inch to come on the table, but I've only got about half an inch here, so I've got to take some material off the bottom of this sensor switch and also tie this cable back. That's high enough for what we want at the moment. So let's make a mark on there. And drop the table down. That's quite a long way off where I expect it to be, but hey, let's not worry at the moment. Oh, what's happening? Something is jamming. It's pretty tight, that belt, but it's still, something is very stiff here, and it's not driving very well at all. That is 4 or 5 millimeters lower there than it is here. Shut that off while we try and sort this problem out. Now, this is not part of the plan, but hey, the way in which you adjust these, make the table level, is on these pulleys. Normally somewhere you should find a couple of grub screws fixing the pulley to this shaft. Now you need to undo those grub screws if you can get to them. You need to rotate this to take the table up or down. Wow, this table is out by a long way, about the same level as that one. And then that one at the back is totally wrong as well. But that one looks as though the grub screw is loose, and that may well be what the problem is. So the back one is about right now. It's reasonably level now, so there shouldn't be jamming. Damn well are. So now we've got to defuse this little time bomb that our Chinese friends have sent me. I've taken the belt off so that I can actually feel each one of these, and that one is pretty free. The one at the back there, marginally stiff, but not as free as I'd like it. Certainly not as free as this one. This one over here is pretty free as well. This one at the back here is extremely sticky. As it goes up, it gets sticky. As I move it down to out of level, it frees up. I'm suspecting that this bearing here is not lined up properly, and it's clamped out of position. Take all those screws loose and see what this feels like now. No, it's getting tight again. It's getting very tight. And these threads are bent because I can feel them going tight and loose as I rotate them. The gauge that I've got here measures to within 0.1 of a millimetre, so I'm going to set that to exactly 11 here on each corner of the table. They're level as far as the nozzle is concerned, or as far as the head is concerned. It doesn't mean to say they're level with the bottom of the machine, of course. Right, I've now taken the motor off, and I can see why this doesn't rotate. It's got a planetary gearbox associated with the motor. Right, but what I've now done, I've taken the original gear off, which was pathetically slow, remember, at raising and lowering the table, and I've found this matching gear from another machine, and well, look at the size difference. It's going to go up and down like a rocket now. I've just come to fix this motor back on, and several things you can see. First of all, it's very unstable. You can see how it's actually only fixed to a very paper thin floor of the machine, and M4 screws through a piece of metallic paper is not exactly a very good idea, is it? I mean, I've already stripped 3 of the 4 threads on there, and let me just demonstrate something. There we go. That's how strong those threads are. So it's something else I've got to fix. So with the torque on this motor and the flex, no wonder it's not possible to tension it up properly, and it keeps going click, 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 click. I'm very lucky in that I've got all sorts of kit. I've got a piece of 3mm stainless steel plate there that I will be able to just conveniently fix in there and bolt that to. And that will stop it from flexing. Well, this larger pulley, which hopefully was going to make the thing run faster, was just asking too much of the torque available from this motor. So I've had to put the original small drive pulley back, and it looks and feels a lot better now that we've got the motor mounted really stiff. It can't jump teeth with this amount of tension on the system. So what we've got to do now is to go around the other side of the machine, and again we've got to set the table level. Now, while I've been messing around with this table and levelling it all up, I keep getting bugged by this loss of power, increase in beam size. Look, we've got a lovely tight beam there, and yet by the time we get to the end of the stroke we've got a fuzzy beam just across this x-axis. Is it a mirror problem, or is it a distance problem from the tube that's causing the beam to grow? I don't believe it is, but of course I will never know until I prove it. So we're going to have a look at see how this beam grows with distance. I can do that on this machine because of the way in which I've designed the tube mount. So let's go and have a look, and I'll show you what I mean. Having set this beam up in the x-axis to give the correct position on mirror number 2, I don't really want to lose that. So what I've done, I've marked at this end the position, and I've also put a mark that end at the end of my tube mounting. So what I can now do, I can with impunity undo my tube, because I know that it's referenced off the back face, and I can always put it back into the correct position on the back face. We'll take the front clamp screw out, and I've very slightly loosened the rear one. So that means I can now do this with my tube. I can pull it out like this. So all I've got to do is remove my mirror now. And provided I push it back just a little bit more, I can move my beam out beyond the end of the machine, because it will fire through the mirror now. And if I line you up properly, you are looking down the barrel of a gun. What I'm going to do is I'm going to fire the laser at various distances into a piece of card, and we're going to see how the beam changes shape with distance. So, by the time we get to mirror number 3, we are 1260 millimeters away from the face of the laser. Now, I've got some large sheets of card here, which I use for making boxes. We shouldn't be able to miss this, should we? So there we are. We're roughly 1300 millimeters away from the laser tube now. So let's turn it on. Same 10% power, and let's see what we can do at 1300 millimeters. There it is there, look. Let's just see whether or not that is the dot, so that I can look at it from a distance. Let's see if I can make it bigger. No, the dot is actually here, look. There's my dot there. So, we are not overly impressed, are we? It's losing power with distance, and it's also, the beam is growing quite substantially with distance, and I'm having to hold the power on for quite a long time. Now, I could push the power up and see what effect that has. We could move this across a bit, and I'll push the power up to 100%. Max power. So let's just see what happens when I go beep at 99%. Wow, that's a pretty abysmal beam, isn't it? That's not a mode 0 beam. I was sent this test certificate with this laser. Now look at all this data up here, and I can't find anything about distance away from the head when they measured this data that you can see here. This very clearly shows a lovely, what they call TEM00, proper Gaussian shaped beam. And then they do all sorts of statistics on this graph down here about the Gaussian fit. But at the end of the day, we don't have a Gaussian beam 1.3 meters away from the lacer. As I said, a Gaussian beam is described as a TEM00 mode. What we have here is, well, it's the shape of my bottom almost. So it's a TEM01 beam that we've actually got. And I can do nothing with that. I mean, it may cut okay, it may weld okay, but it certainly won't be any good for laser engraving because there is no sharp point. This is not going to work for me. So I'm not going to go any further with this exercise until I've spoken to Cloud Ray. As I was editing my video, and remember we looked down the barrel of the gun, if the beam was small and compact and passing right through the centre there would not have been a problem. But bear in mind, I think this beam is expanding, and therefore there is the possibility that I could be getting reflections off the side as it passes through this mirror aperture. So what I'm going to do is to remove the mirror before I finish up with egg on my face, and we'll try the same thing again. Not entirely sure where it's going to land, but it's going to be somewhere about there. Oh, that's a coincidence, it's right in the same spot. Let's just move that across a little bit. That's just a quick single pulse. We have still got a TEM00 beam at 1.3 meters after all, which is excellent news. We'll just stick one of my paper targets on there so that we've got a nice consistent material to work with. I'm not going to touch it, I'm going to do it again and see if I can just burn the centre out. So we'll just watch for the red glow. Is it in the centre? Yes. So we have got quite a nice beam after all. Yeah, look at it, it's huge. So that beam is almost 10 millimeters diameter. We certainly don't need any beam expanders on here. The beam expands on its own, thank you. So by the time we get to our lenses, we have got a relatively low energy density. So that's good news because, hey, anything that we interpose in the path is going to absorb power. And we've only got 30 watts here anyway, so you know, we want to make the most of that. So I'm very happy that we're not going to have to use a beam expander. So this has been a very interesting exercise. Down, up, and eventually we can carry on. So what we've just found out is that the beam grows as it reaches mirror 3, and by the time it gets there it's 10 millimeters diameter. Now you've got a 25 millimeter mirror which is canted over at 45 degrees. That means the effective height of that mirror that the beam can see is only around about 14 or 15 millimeters. So we've got to be pretty accurate with our alignment onto mirror 3. But the good news is, because of the way in which we align mirror 3 with the centre of the axis of the lens tube, then we're automatically going to put the beam onto the sweet spot of mirror 3, which is the central point, if I've designed it correctly. So things are looking pretty good. For the next week or two, I've got other projects that I've got to get involved with. I might not be completing this work for a little while yet, so you'll have to be a little bit patient. But now you've seen that we've got a working machine. We're flying! And on that happy note, I'll say cheerio for now. Thank you for your time and patience, and I'll see you in the next session.